Let's solve few more problems on the Bernoulli equation. Solve dy by dx plus y by x is equals to y square x into sin x. So the given equation is dy by dx plus y by x is equals to y square x into sin x. So already the coefficient of dy by dx is 1. Now we have to make the q of x right hand side as a function in terms of x. So we have to eliminate this y square. So to eliminate this y square, we have to multiply with y power minus 2 on both sides. So y power minus 2 nothing but 1 by y square. When we multiply here, y square will be get cancelled. So we have to multiply with y power minus 2 on the both sides. So when we multiply here, we get y power minus 2 dy by dx plus y by x into y power minus 2 is equals to y power minus 2 into y square x sin x. So here y power minus 2 dy by dx plus 1 by x into, that is y power 1 into y power minus 2. When bases are same, powers will be added. So 1 minus 2 is minus 1. So 1 by x into y power minus 1, and that equals to, this both terms gets cancelled and the remaining is x into sin x. Let this be as equation number 1. Now from this we have to take the y variable, that is y power minus 1. We have to assign it to the another variable. We are taking here v. So let y power minus 1 is equals to v as a second equation. Now we have to differentiate this with respect to x. So when we differentiate with respect to x, we get minus 1 y power minus 2 by using the formula n into x power n minus 1, that is minus 1 minus 1 is minus 2. So that is minus 1 into y power minus 2 dy by dx. Here we are getting dx because we are differentiating this with respect to x, and that equals to dv by dx. Now send this minus 1 to the right hand side, because in the equation 1 we have only y power minus 2 into dy by dx. So we have to substitute this value. To get this value here, we have to send the minus 1 to the right hand side. So when we send, we get it as y power minus 2 dy by dx is equals to minus dv by dx. Let this be as equation number 3. Now substitute this equation number 2 and equation number 3 in the equation number 1. So when we substitute here, y power minus 2 dy by dx is minus dv by dx. Substitute this value here. You get it as minus dv by dx plus 1 by x. Y power minus 1, we know that we took the variable as v. So substitute here, we get 1 by x into v is equals to x sin x. Now we have to make the coefficient of dv by dx as 1. So to make the coefficient of this one, we have to multiply with minus 1 on both sides. When we multiply here, minus into minus becomes plus. So when we multiply with the minus 1, we get it as dv by dx minus into 1 by x v, that is minus 1 by x v is equals to minus x sin x. Now we know that it is in the form of dv by dx plus p of x into y is equal into v is equals to q of x, as we did in the linear equations. So the same procedure is same. Now we have to take the functions p of x and q of x, which are the functions in terms of x variable, and we had to find out the integrating factor and the general solution. So when we compare this equation with this formula, we get p of x is a function in terms of x. So p of x is minus 1 by x, and q of x is also function in terms of x. Then q of x is minus x into sin x. Now integrating factor is equals to e power integration of p of x into dx. So we have to substitute the p of x, that is minus 1 by x. Then we will get the integrating factor. Now integrating factor is equals to e power integration of p of x into dx, that equals to e power, right, minus outside of the integration, then you get minus integration of 1 by x into dx, that equals to e power minus 1 by x integration is log x. So that can be written as x power minus 1. That is here minus log x can be written as log x power minus 1. We know that e power log x power can be written as x power n. So here x power minus 1 can be written as x power minus 1. That is a integrating factor is equals to 1 by x. Now we have to find out this general solution, that equals to v into integrating factor is equals to integration of q of x into integrating factor dx plus c. So v into integrating factor is 1 by x, that equals to integration of q of x is minus x sin x into integrating factor is 1 by x dx plus c. So v into 1 by x is equals to integration of x and x get cancelled, then you get minus sin x dx plus c. So v of 1 by x is equals to, minus can be written outside, integration of sin x is minus cos x. So plus c. Then we have to substitute the value of v in this. We assumed v as y power minus 1. Now substitute this here, we get it as y power minus 1 into 1 by x is equals to, minus into minus is plus cos x plus c. Or it can be written as, send this y power minus 1 to the denominator, then you get 1 by xy is equals to cos x plus c is a general solution. Then second question, solve dy by dx plus y tan x is equals to y square into sec x. So this is a given equation. Now we have to make the right hand side function to be free from the y variable. We have to eliminate this y square. So to eliminate this, we have to multiply this equation with the y power minus 2 on the both sides. We know that y power minus 2 nothing but 1 by y square. So when we multiply here, y square will be getting cancelled. So now multiply this y power minus 2 on the both sides. Then we get it as y power minus 2 dy by dx plus y into y power minus 2 tan x is equals to y power minus 2 into y square sec x. So y power minus 2 divided by dx plus y power 1 into y power minus 2 is y power minus 1 tan x is equals to, this will get cancelled, then the remaining is sec x. Let this be as equation number 1. Now we have to take from this function, we have to take the y variable, that is y power minus 1, and we have to assign it to one variable. So let y power minus 1 is equals to v, and let this be as equation number 2. Now we have to differentiate this equation with respect to x. So when we differentiate here, we get minus 1 y power minus 1, that is minus 2. We know the formula, n into x power n minus 1. So by using this formula, we get minus 1 y power minus 2, and since we are differentiating with respect to x, we get dy by dx, and on the right hand side also we get dv by dx. Now when you see in this question y power minus 2 divided by dx, we have to get the value here. So to get the value here, send this minus 1 to the right hand side, then we get it as y power minus 2 divided by dx is equals to minus dv by dx, and let this be as equation number 3. Now substitute the equation number 2 and 3 in the equation number 1. Now substitute the equation 2 and 3 in equation 1, we get it as minus dv by dx plus v tan x is equals to sec x. Now we have to multiply with minus 1 on the both sides, because we have to make the coefficient of dy by dx as positive. So here when we multiply with minus into minus become plus. So we get it as dv by dx minus v tan x is equals to minus sec x. Now it is in the form of dv by dx plus p of x into v is equals to q of x. Now when we compare this equation with this formula, we get p of x and the q of x are the two functions in terms of x variable. So here p of x is minus tan x, and here q of x is minus sec x. Now integrating factor will be e power integration of p of x into dx, that equals to e power integration of p of x is minus tan x into dx. Then that equals to, minus can be written outside of the integration, then we get e power minus integration of tan x into dx. So that equals to e power minus tan x integration can be written as log sec x. So minus log sec x can be written as log sec x whole power minus 1. Then we know that e power log x power n can be written as x power n. So similarly sec x whole power minus 1 can be written as sec x whole power minus 1. So that can be written as 1 by sec x. Now integrating factor is 1 by sec x, and the general solution will be v into integrating factor is equals to integration of q of x into integrating factor dx plus c. So v into integrating factor is 1 by sec x, that equals to minus integration of q of x is sec x into integrating factor is 1 by sec x into dx plus c. So minus can be written outside of the integration. That is, then v of 1 by sec x is equals to minus integration of, here sec x and the in the denominator sec x get cancelled, then remaining is 1 dx plus c. Then remaining is 1 dx plus c. So v by sec x is equals to minus integration of 1 is x plus c. Now we have to substitute the value of v here. That value of v is y power minus 1. Then when we substitute here, we get y power minus 1 sec x is equals to minus x plus c. So we can even take the y power minus 1 to the denominator. That we get it as 1 by y sec x is equals to minus sec x minus x plus c is the general solution for this question. So let's see the another question, that is solve dy by dx plus x sine 2y is equals to x cube cos square y. So this is a given equation. Now we have to make the right hand side term should be free from the y variable. So we have to eliminate this cos square y. So to eliminate this cos square y, we had to multiply with cos square y whole power minus 1. If you are getting confused with this, then you can write a statement that divide with cos square y on both sides. So here when we multiplying with cos square y whole inverse is same as the dividing the equation with cos square y. So if you write this statement, then it will be very easy. Then there will be no confusion. So write divide with cos square y on both sides. So when we divide here, we get 1 by cos square y into dy by dx plus x sine 2y by cos square y is equals to x cube cos square y divided by cos square y. So cos square y will be cancelled here. Then we get 1 by cos square y can be written as sec square y. So into dy by dx plus x into sin 2y formula we have it as. So here sin 2x formula is 2 sin x cos x. So in the place of x we are having y variable here. Then this can be written as 2 sin y cos y divided by cos square y is equals to x cube. Here cos square y will be cancelled. Then sec square y divided by dx plus 2x. Here cos y will be cancelled. Then remaining is 2x sin y by cos y is equals to x cube. So sec square y divided by dx plus 2x sin y by cos y can be written as tan y is equals to x cube. Now let this be as equation number 1. So now we had to take from this term, we had to take the y variable, that is tan y, and we had to assign this variable to the another new variable, that is v. So let tan y is equals to v be as equation number 2. Now when we differentiate this with respect to x, we get sec square y, that is tan y differentiation is sec square y to dy by dx is equals to dv by dx. Now here when we had to substitute this value in this equation. So substitute the equation 2 and 3 in the equation number 1. Then we get sec square y dy by dx, we got the value as dv by dx. So we got the value as dv by dx plus 2x into tan y, we know the value is v is equals to x cube. Now it is in the form of dv by dx plus p of x into v is equals to q of x, where p of x and the q of x are the functions in terms of x variable. Now when we compare this equation with this formula, we get p of x is 2x and q of x is x cube. Now we have to find out the integrating factor. So integrating factor is equals to e power integration of p of x into dx, that equals to e power integration of p of x is 2x into dx, that equals to e power 2 can be written outside of the integration because it is a constant. So 2 integration of x dx, then that equals to e power 2 into x integration is x square by 2 by using the formula x power n plus 1 by n plus 1. So here n nothing but 1. So 1 plus 1 by 1 plus 1, that is x power 1 plus 1 is 2 x square by 2. Now integrating factor is equals to, here 2 will be cancelled, then integrating factor will be e power x square. Now we have to find out the general solution. So here general solution is v into integrating factor is equals to q integration of q of x into integrating factor dx plus c. So v into integrating factor we got e power x square, then that equals to integration of x cube is q of x is x cube, and the integrating factor e power x square dx plus c. So we cannot integrate it directly. So let's assume x square as t. So before this we can split the x cube term as x into x square. So now let x square be another variable, that is t. So here we have to differentiate with respect to x, then we get x square differentiation is 2x into dx is equals to dt. So x dx, send this 2 to the right hand side, we get dt by 2. Now substitute these values in this equation, we get v into e power x square, we already assumed it as t. So v into e power t is equals to integration of x into dx. X dx can be written as dt by 2. So dt by 2 we have written here. Then x square we assumed it as t into e power x square is e power t. So v into e power t is equals to integration of t into e power t dt by 2 plus c. So v into e power t is equals to, these two can be written outside of the integration since it is a constant. So 1 by 2 integration of t into e power t dt plus c. Now here we can use the formula when there are two functions which are multiplying. We have to use this formula, that is integration of u into v dx is equals to u integration of v minus u dash double integration of v plus double derivative of u triple integration of v, and this process goes on continue until the term becomes 0. So v into e power t is equals to 1 by 2. This is u here, u is t and v is e power t. First we have u into integration of v, so that is t into integration of e power t is e power t minus derivative of u. So differentiation of t with respect to t is 1 into double integration of v. So since we have already integrated it one time, when we integrate it another time we get the double integration. So e power t integration is e power t plus double derivative of u. So u dash is 1. When we differentiate it again we get the double derivative. So constant differentiation is always 0, and when we multiply this 0 to the triple integration or whatever it is, the whole term becomes 0 plus c. So v into e power t is equals to 1 by t integration of, from this both we can take e power t common. So e power t of t minus 1 plus c. Now we have to substitute the value of t, that is t is equals to x square. When we substitute here, v into e power x square is equals to 1 by 2 of e power x square minus 1 plus c. Now we should also substitute the value of v. So substitute v value, that is v is equals to tan y. When we substitute here we get tan y into e power x square, that equals to 1 by 2 of e power x square minus 1 plus c. So this is the general solution. Let's solve the final question on the Bernoulli equation, that is dy by dx is equals to x cube y cube minus xy. So send this xy to the left hand side, then you get dy by dx plus xy is equals to x cube into y cube. Now we have to eliminate this y cube from the right hand side. So we have to multiply with y power minus 3 on both sides. Then we get y power minus 3 dy by dx plus x into y power minus 3 is equals to x cube y power minus 3. So y power minus 3 dy by dx plus x into y power 1 y power minus 3. So when bases are multiplying, then powers will be added. So minus 3 plus 1 is minus 2. That equals to, here these two terms get cancelled, then remaining is x cube. Now let this be as equation number 1. Now from this middle term we have to take the y variable and we have to assign it to the another new variable. Let it be as v. So here y power minus 2, I am assigning it to the variable v, that is y power minus 2 is equals to v, be the equation number 2. Now when we differentiate this, we get minus 2 y power minus 3 dy by dx is equals to dv by dx, since we are differentiating with respect to x. So now here when you see in the question we have y power minus 3 dy by dx. So now to get this here, send this minus 2 to the right hand side. Here it is multiplying. When it goes to the right hand side, it goes into the denominator. Then we get y power minus 3 dv by dx is equals to minus 1 by 2 dv by dx. Now substitute this value 2 and 3 equations in the equation number 1. When we substitute the values, we get y power minus 3 divided by dx is minus 1 by 2 dv by dx plus x into y power minus 2 is v, that equals to x cube. Now we had to make the coefficient of dv by dx as 1. So to make this as 1, we had to multiply with minus 2. When you multiply with minus 2, then the coefficient of dv by dx becomes 1. On the both sides, you have to multiply it. So minus 2 into minus 1 by 2 dv by dx plus minus 2 into x into v is equals to minus 2 into x cube. So minus 2 into minus is plus, 2 by 2 is 1. So dv by dx minus 2x into v is equals to minus 2x cube. Now it is in the form of, we made the coefficient of dv by dx as 1. So it is in the form of dv by dx plus p of x into v is equals to q of x. So from when we compare this equation with the formula, we get p of x is minus 2 into x and q of x is minus 2x cube. Now we got the p of x and the q of x. We had to find out the integrating factor and the general solution. Then here integrating factor is equals to e power integration of p of x into dx is equals to e power integration of p of x is minus 2x into dx, that equals to e power minus 2 can be written outside of the integration since it is a constant. So e power minus 2 integration of x dx, that equals to e power minus 2, x integration is x square by 2. Then x will be cancelled here. Then we get e power minus x square. So integrating factor is equals to e power minus x square. Then general solution will be v into integrating factor is equals to integration of q of x into integrating factor dx plus c. So v into integrating factor is e power minus x square, then that equals to integration of q of x is minus 2x cube into integrating factor is e power minus x square dx plus c. So v into e power minus x square is equals to minus 2 can be written outside of the integration, and here we cannot do the integration directly, so we had to assign one variable to another new variable. So here we can split the x term as x into x square and into e power minus x square dx plus c. Now let us assume x square as another variable, that is t. Now we have to differentiate this with respect to x. We get 2x into dx is equals to dt. Now send this 2 to the right hand side, you get x dx is equals to dt by 2. Now substitute these values in this equation. Now v into e power minus x square is t. So that is v into e power minus t is equals to minus 2 integration of x square is t and e power minus x square is e power minus t, and x dx can be written as dt by 2. So I have written here dt by 2 plus c. Now send this minus 2 to the outside of the integration. We get v into e power minus 2 is equals to minus 2 by 2 integration of t into e power minus t dt plus c. So minus 2 by minus 2 can be written as minus 1. So here 2 will be cancelled. Then v into e power minus t is equals to minus integration of t into e power minus t dt plus c. So here integration by using the formula, here the two functions are multiplying, that is t and e power minus t. So by using the formula, integration of u into v dx can be written as u into integration of v minus u dash double integration of v plus u double dash triple integration of v. So v into e power minus t is equals to minus of, here u is t and v is e power minus 2. So u is t, that is t into integration of v, integration of e power minus t is e power minus t. So minus u dash, derivative of u, derivative of t is 1 with respect to t, into double integration of v. Single integration of v is e power minus t. When we integrate it again, then it becomes double integration. So e power minus t integration is also again e power minus t plus double derivative of u. So single derivative of u is 1. When we derivate it again, we get the double integration. So constant integration is always 0. When we multiply 0 with anything, it becomes 0. So from here we get all the terms 0. So we can stop the integration here. Plus c. Then v into integrating e power minus t is equals to, here we can take the e power minus t common, that is minus e power t of t minus 1 plus c. Now v into e power minus t is equals to, t can be multiplied inside, then it becomes minus t plus 1. I mean, it can be written as 1 minus t. So e power minus t of 1 minus t plus c. Substitute the t value, that is t is equals to x square. When we substitute there, we get v into e power minus x square is equals to e power minus x square of 1 minus x square plus c. Now we have to substitute the value of v also. So v is y power minus 2. Then when we substitute in this, we get y power minus 2 into e power minus x square is equals to e power minus x square of 1 minus x square plus c. Or this can also be written as, send this y power minus 2 and e power x square to the denominator. We get 1 by y square e power x square is equals to e power minus x square of 1 minus x square plus c. So this is a general solution. So here we have discussed the 4 problems. Those 4 problems are the most important questions, and those are repeated in exam also. So prepare those questions perfectly.